Congratulations on making it to our final module. Theory is great, but applying what you've learned is key. This module will guide you through your Capstone Project, a chance to build a real AI/ML solution. The Capstone Project is your opportunity to synthesize the concepts we've covered, from data pre-processing and model selection to evaluation and even incorporating generative AI elements. It's designed to be a hands-on experience, bridging the gap between learning and doing. Here's how to approach it. First, define your problem. Choose a problem that genuinely interests you and for which you can find relevant data. This could be predicting house prices, classifying images, analyzing customer sentiment, or even building a small generative text model. Brainstorming ideas with a generative AI twist. Text generation. Can you train a small LLM or fine-tune a pre-trained one to generate creative stories based on prompts? Or generate product descriptions? Image generation. Could you use a simpler generative model like a basic GAN or VAE to generate patterns or simple images? Or use a text-to-image API for a creative art project? Data augmentation. Can you use generative AI to create synthetic data to augment a smaller data set for a supervised learning task? For example, generating more varied text examples for sentiment analysis. Chatbot with LLM API. Build a simple conversational agent that leverages a powerful LLM API for its responses, focusing on a specific domain. For example, a simple health info bot. Think about the data availability, the complexity you can handle, and your personal interest. Start small, get something working, and then iterate and expand. Remember the ML workflow: data, pre-process, model, evaluate. Your project should demonstrate your understanding of the core ML concepts and, ideally, incorporate a generative AI component or leverage a Gen AI tool. Focus on the process: cleaning data, selecting appropriate models, evaluating their performance, and presenting your findings. The Capstone Project is your chance to shine. It's where theory meets practice. In the next lecture, we'll discuss what happens after your model is built: deployment and MLOps. Building a great machine learning model is only half the battle. To deliver real value, that model needs to be used in a live environment, making predictions or decisions. This is the realm of model deployment and MLOps, machine learning operations. Deployment means taking your trained model and integrating it into an existing application, system, or service so it can process new, real-world data. This could be a web application, a mobile app, a backend API, or an embedded device. Think about the journey. Your data scientist builds the model in a notebook, but how does that model then serve millions of users with real-time predictions? This requires transforming the model into a runnable service, often using frameworks like TensorFlow Serving, Flask, or Fast API, and hosting it on cloud platforms like AWS, Google Cloud, or Azure. Now let's talk about MLOps. Just as DevOps revolutionized software development by streamlining collaboration and automation, MLOps aims to do the same for machine learning. It's a set of practices that combines ML, DevOps, and data engineering to standardize and streamline the entire ML lifecycle. Key pillars of MLOps include reproducibility, ensuring that experiments and model training can be replicated reliably; version control, tracking not just code, but also data versions, model versions, and experiment configurations; continuous integration, continuous delivery, CI/CD, automating testing, building, and deploying models; automated retraining. Models can degrade over time due to data drift, changes in data distribution. MLOps helps automate the process of periodically retraining models with new data. Monitoring. continuously tracking model performance in production, for example, accuracy, latency, fairness metrics, and detecting model drift or data quality issues. For generative AI models, MLOps becomes even more complex, ensuring quality control over generated outputs, preventing undesirable content generation, and managing the vast computational resources required for inference are unique challenges. MLOps bridges the gap between research and production. It ensures that ML models are not just built, but also reliably deployed, monitored, maintained, and continually improved in dynamic real-world environments, extracting maximum value from your AI investments. Understanding MLOps is becoming increasingly important for any aspiring AI ML professional, as it's key to successful, scalable AI implementation. And with that, we move to our final review and next steps. Congratulations on completing this comprehensive journey through artificial intelligence, machine learning, and the exciting world of generative AI. It's been a privilege to guide you. Let's quickly recap what we've covered. We started with the fundamentals, understanding different types of ML, supervised, unsupervised, and reinforcement learning, and the essential ML workflow from data to deployment. We learned about data pre-processing and model evaluation. Then, we delved into deep learning, building neural networks, understanding backpropagation, and exploring specialized architectures like CNNs for computer vision and RNNs/LSTMs for sequential data. We saw how AI helps machines see and understand images. We then moved to natural language processing, transforming text into numbers, performing sentiment analysis, and most importantly, understanding the revolutionary transformer architecture that powers modern LLMs. This set the stage for our deep dive into generative AI. In generative AI, we distinguished it from discriminative AI, explored foundational models like GANs and VAEs, and then went in-depth on large language models and diffusion models for image and multimedia generation. We also learned the crucial skill of prompt engineering to guide these powerful AIs. Finally, we revisited reinforcement learning for sequential decision-making and critically examined the ethical considerations and responsible development of AI. You now have a solid foundation across the core domains of modern AI. What are your next steps? Practice, work on your capstone project. Deepen your knowledge, explore specialized topics like specific algorithms, frameworks, TensorFlow or PyTorch, or specific applications like more advanced NLP, robotics. And stay updated. AI is a fast-moving field. Follow research, blogs, and industry news. Join communities, engage with other learners and professionals. The world of AI is vast and constantly evolving, and you're now equipped to be a part of it. Thank you for joining me on this incredible journey.